Bueno, continuamos con el doctor Peter Reinken en la exposición titulada Enfoques de la seguridad en espacios subterráneos, métodos y principios esenciales.
Yeah, thank you very much. So my talk will be more focused on rail tunnels, safety, fire safety of rail tunnels. And then in the second part, maybe this is after the coffee break, I guess, I will then talk about tunnel ventilation of rail tunnels. So these are the two key elements of the next couple of minutes. So I then may start with some general slides again. So what you here see on this slide are a couple of different functions of tunnels and combinations of them. So what we can learn is that metro tunnels and station are only one type of various other functions of tunnels. As you are well aware, and you have heard already yesterday presentations, there are various, objectives of tunnels, and of course this then leads each time to some individual design. This is true for metro tunnels itself as well. So that's one thing, and then metro tunnels appear in a variety of layouts and combinations, so there is not just one system in the world, but there are hundreds of different systems, and this then applies to the safety concepts of ventilation as well. Another thing about safety and ventilation is that this is, of course, only a small part of the design. Tunneling is a multidisciplinary field of activities, engineering activities. Many things have to work together. So the key thing about safety and ventilation, of course, is interface management to the civil layout, to the, well, it starts with the geotechnical things, but as well then with the rail system and so on. So safety and ventilation is only one small part of metro design. Here we have narrowed down a little bit already the topics. What you see here are aspects related to ventilation, aero and thermodynamics and fire life safety in rail tunnels. So, for example, if we start with comfort, safety related to airflow in the middle, you may put this subject under the headline of tunnel ventilation, but you may say as well, this is tunnel aerodynamics, or this is tunnel environmental control. It's as well part of fire life safety aspects, control the air velocities and so on. So the purpose of this illustration is to show that you cannot look at ventilation only or at fire life safety only. Many topics are connected, and in an urban metro system or in a high-speed railway system, you have to look at all these topics together and then see that the interfaces are correct. What is shown here as well are the key interfaces to other systems. So the civil works, the electromechanical systems. Then there are issues to clarify with the rolling stock, and then with the later operation of the metro system. So this is sort of the thematic network. Again, it is very important in the design to clarify all these interfaces as early as possible in the design process, or if there is later some refurbishment, to look at all these aspects together. I'm not going to every topic here, but it just shows that there are various things to be considered. Now, safety and ventilation in rail systems is the focus of this presentation. There are, of course, many other things which are relevant for the safety in railway systems. Apart from vehicle fire, there are issues like derailment is a possible risk, collision with obstacles and other vehicles in the tunnel, cable fires, collapse of infrastructure, overcrowding, explosion, terror, and so on. They were already mentioned partly. So all these things are relevant for safety. The particular thing about fires, and here the vehicle fire is always in the focus, the particular aspect here is that with proper treatment, you can still influence the consequences of an incident. So if a train derails, then the damage is there and there are victims, but in the later minutes of the incident, you cannot change much anymore. The damage is there, but in fire, it is very important to then react properly. So, for example, to provide rapid smoke control. So that's why there is often the focus, if there is discussion about safety, then it's about fire safety. In general, we can say that apart from the incidents we had in the last decades, tunnels are still the safest element of traffic networks. So they are not, how should I say, particularly dangerous, but fires are considered to be the most severe incidents. They have the potential for a disaster. In difference to other incidents, as I said, you can mitigate the consequences of a fire by appropriate measures, so egress, ventilation, and so on. And the other point why this aspect of fire safety is so important, it's a very important cost driver for a project. So the fire measures, they have a major impact on the civil layout, on shafts and so on. And of course, this then makes projects expensive or a little bit less expensive, to put it this way. Now, there are different approaches to safety, and in reality, it's all a mixture of this. But you can distinguish between four major approaches, sort of. One is a prescriptive or legislative approach. So you check whether your proposal, your design, meets certain standards or laws or guidelines. The other approach is to do qualitative and quantitative risk assessments. So you identify the risks which are there in your metro system and check whether your safety objectives are met. You can do probabilistic calculations and so on and see, do I meet the overall safety target? Another approach is then the state of the art. So what do they do in other projects? Then I'm probably supposed to do the same. That's as well an approach. And then finally, the local experience and preferences. So in some countries, there was some incident some time ago, so they will then probably have particular requirements to handle this type of incident. So you can say these are the basic approaches. Again, in the reality, it's all a mixture of these different approaches. Here you see an example. This is now not metros, but long-distance high-speed rail. You see 3 examples of tunnels which are, the top one is from UK, the HS2 project. That's one 60-kilometer long tunnel. In the middle, there is a 16-kilometer tunnel from Switzerland, and at the bottom, there's a 10-kilometer long tunnel in Germany. You see here different number of ventilation shafts, and each shaft means, in this case, several millions of investments for the shafts themselves, for the civil and for the equipment. And you see that they vary quite a lot. So the Germans, to put it in simple words, they don't do anything apart from putting passive shafts in the middle. And of course there are cross passages and so on. There are a couple of other measures as well which are not indicated here. Whereas in Great Britain, there is a huge amount of ventilation equipment inside. The top one what sort of follow requirements from NFPA 130, this American fire safety standard, and the below one would be the lowest one would follow German standards or requirements. And you see, by choosing the guideline or standard, you have a major impact on costs, and both or all the project owners, they say we have the safest system or the most appropriate system to cover safety. So the purpose of this slide is to show that by choosing the appropriate guidelines or standards, you have a major control or impact on the civil layout. So choose Swiss consultants and you will find reasonable solutions in the middle. No, but you have some influence by choosing the appropriate guidelines. So, and this as well shows that internationally there is not a common agreement on what to do, but the appreciation of risks and the required measures that varies quite considerably. Even within a single country, you will find very different approaches to fire safety. This is just illustrating this. Here there are some standards well established in the world for metros. Here in America, North America, South America, often the NFPA 130 is applied. That's well known. There are similar standards in the world. In the middle, there's an example from Singapore. At the right, that's an example from Germany. And those standards then define main requirements for metro tunnels. They are often structured the same way, so the structural integrity of the civil works should be given. There should be sufficient egress capacity and evacuation path. You are supposed to provide tenable conditions in station, so the focus is really on smoke control in the station boxes. And in some requirements, in some standards, you require as well a flow control in the tunnel. But again, this is an example. In some countries, there are no particular ventilation measures required for the tunnels just because of the very low probability of having a fire there. So that's some examples of standards. Then there are different safety principles given by different standards. Here is an example provided by the UIC or the technical standards for interoperability in Europe. There are others who have the same principles. So the key is always to focus on prevention of incidents, and then the second priority is the mitigation, so to reduce the severe consequences of an incident. And then there are measures for self-rescue and rescue. If we start with these preventive measures, in general, we have to then distinguish, and that's done in these guidelines as well, on underground stations, the tunnels, or ramp sections. Then we have to look at underground depots, turnback facilities, and so on. Then we have to address the vehicles or other ancillary spaces like technical rooms, social rooms, or so, commercial shops, rooms. Then the question is, what is the focus of this? And we are now here in fire safety, so we are not focusing on general rail safety, for example, given by the signaling system or by the trackway design or by other elements of safety. Then a third thing is the objectives. So what is the key thing? The key requirement is certainly to protect the occupants, to protect the passengers and staff. Then second priority is to assure the structural integrity, that the building does not collapse upon a fire. and then certainly we want to have an effective, efficient system regarding fire control, fire safety. Now, here is a list of preventive measures according to NFPA. Of course, I will not go into all the details here, but there's a long list of things you are supposed to do. For example, use non-combustible construction material, prevent flammable and combustible liquid intrusion from street level. So if there is an accident on a street, there should not get gasoline, for example, into the metro tunnels. Requirements on compartmentation of different spaces. You should separate public spaces and non-public floors, areas, and ancillary spaces from the fire safety point of view. You must provide all the additional installations inside and functions. So, for example, selling booths for tickets or other shops. You must assure that they have no non-combustible materials or only to a limited extent. Then you have to separate between system and non-system occupancies. All station public areas must be fire separated from adjacent non-system occupancies. So in order to prevent that the fire propagates and harms essential functionalities like power supply, for example, and so on and so on. I'm not going here into detail. It's a long list of things you are supposed to do. This is only an excerpt from a long list of preventive measures which you are supposed to do for German rail, for underground stations. By the way, this list is a copy of a book like this. It has about 500 pages, and you see how complex fire safety is. Ventilation is only covered here on 4 pages, so you see the extent of aspects to be considered for fire safety. If you wish, you can have a look later. I'm just saying that, of course, behind all these topics, there are many detailed works to be done in order to make a new system or an existing one fire safe. Then, of course, we have the part of rolling stock. After decades of development, there is now a latest norm, at least in Europe, but I guess it will be applied worldwide, about railway applications, fire protection on railway vehicles. So the key here is that the vehicle cannot burn. Today they say that you can throw a bottle of benzene or a Molotov cocktail into a vehicle and it will not burn just because of all the fire-resistant material. Again, you have here long lists of requirements. This is only a very small part of these requirements for latest passenger rolling stock. So they specify in details what cables, for example, you are allowed to use, what materials you can build in, and so on. But certainly the train fire safety is a key aspect of fire prevention. Then there are other measures, often for long-distance tunnels. They focus as well then not only on passenger trains but on freight trains. So the loading gauge is checked at regular or at certain points, for example, in front of long tunnels. We have hot axle box detectors, derailment detectors, and other systems, as you see here. And when there is any normality indicated or detected in front or before passing a tunnel, these trains then are stopped before they enter the underground part. I guess there are similar systems as well for metro systems or onboard checking systems. Then a last example of a preventive measure is the choice of the tunnel system. So do we have a twin bore tunnel system or single bore twin track system. Of course, choosing already two tubes leads to avoiding certain incidents, for example, derailment, or avoids collision. So by this, you can already prevent fire as well by already splitting up the different traffic directions. Now this slide is for preventive measures. The same slide appears now under mitigation measures. So we come now to, after the preventive measures, to mitigation measures. So here the target is to reduce the consequences of a fire. And here we have as well the principle of two tubes connected with cross passages. So as a measure to reduce the fire impact, we have the parallel tube as a safe area. You can walk over from the incident, from the fire tube to the non-incident tube. And this is now becoming more and more typical for long distance tunnels to implement twin tube systems as well, of course, for metro systems as well. Cross passages are installed depending on the guideline you follow every 200, about 50 meters to 500 meters. The other approach is to have a single tube. Here you are supposed to introduce egress shafts or adits to allow at regular distances an egress. I guess the minimum standard today is to have such a shaft every 1,000 meters, but there are a couple of projects where the distances are shorter. So this is as well a major mitigation measure to allow egress and access by emergency forces. Here is an example from Austria with the combination of a road tunnel and a rail tunnel. So these two tubes are connected at regular distances by those adits. In between there is some chamber for waiting. So this allows then for both to evacuate in the road tunnel, if there is a road tunnel accident, to evacuate towards the waiting room, and you can as well evacuate from the rail tunnel. Now there are as well a couple of different examples around where those combinations are done as well. So we started with the mitigation measures. We looked at tunnel concepts. Further aspects of mitigation are to provide reasonable fire resistance of the structure, to provide escape walkways, emergency lighting on escape routes. Electricity supply is important. Rescue areas outside the tunnels are an issue of mitigation. Emergency communication, access for rescue services, and overhead or third rail earthing is as well a measure. I will show now some examples on this. These are different temperature curves, so the structure should be able to resist those thermal loads without major damage. Again, I'm not going into detail about this, but this is for the civil design, for the concrete features, for example, a major aspect of mitigation. Then again, this major requirement is as well, and now well established, that you are supposed to provide sidewalks or egress path. For example, according to the European TSI on interoperability, you need to provide 0.8 meter wide walkway, German rail 1.2 meter wide, or NFPA 130 0.8 meter wide along the train and at a height of 1.6 meters, so sort of very similar. This was not the case, let's say, 50 years ago, so there are many tunnels which don't have any walkway. So this is certainly today common standard to provide those egress paths, and then you have then the exit somewhere outside. There are only two examples shown here. So these are then the vertical access shafts or stairwells which go to street level. Another important thing is, of course, are the escape signs or the light in general. So there are different versions of them. Just a little note on the color. Some have blue lights or blue signs as well to indicate them in order to avoid any confusion with the green lights for the train drivers. But this is a minor issue. But of course, it's very important to have at close distances those emergency signs, combined then, of course, with other things for evacuation and rescue, like you need to have handrails to allow as well under bad visibility to allow fast walking on the sidewalk. Further mitigation measures are then rescue areas outside the tunnels and stations. So if there is an incident in the tunnel, you all of a sudden are faced with many rescue vehicles outside the tunnels. They need space. So there should be areas at the tunnel portals. If the tunnels are long on both sides, shorter tunnels at one side only. The roads need to be accessible by common rescue and firefighting vehicles, and where possible, you should as well at least know where helicopter landing would be possible in the vicinity. Another mitigation measure is the water supply, so you need to be able to provide water to at least the portals or emergency exits. That's common standard. In some tunnels or countries, it's required to have a dry pipe all along the tunnel in order to support the fire brigades in extinguishing the fires. You must then as well be able to provide certain quantities. One example is given here, 800 liters per minute, and this should then be able or be possible for 2 hours. Here are just 2 pictures illustrating this. So water supply and some access area at the portal. So at least in new long distance railway lines or as well urban railway lines, this is becoming or is a standard to have those facilities at rail tunnels. Then, of course, you need emergency communication. You need to be able to communicate with the emergency forces. Then these communication systems must be as well able to continue service even if there is a severe fire in the tunnel. So it must be robust system. There are different national standards on this in Europe, at least, so communication, of course, is important. Other examples of mitigation measures are shown here. So you need access for the rescue phases. So if the tunnel is 5 to 10 kilometers long, you are supposed to support the emergency forces by, so for example, devices to carry equipment or victims of those or injured people on those rolling caps. You find them in every longer tunnel now as well, again to support rescue activities. Another aspect is then the earthing. So typically you are allowed to evacuate from a rail vehicle when the catenary is still on power, at least in various long-distance passenger rail tunnels. If you have a third rail and you want to evacuate along the trackway, you need to do the earthing immediate. And of course, it's very important to be able to do the earthing quite fast. So there are systems at egress shafts, for example, where you can do this earthing of the catenary by just pushing an emergency button that's mechanized, or you have to provide manual earthing devices all along the tunnel at certain access points. So that's shown in the lower image. So, but earthing, of course, is a major aspect as well. At least certain rescue activities or firefighting activities can only start if the system is depowered. Then we have mitigation measures at trains as well. So there's a long list of possibilities or of things which are required. Fire extinguishers, fire protection for freight trains, fire barriers inside long trains to separate different parts of the train. Then there are additional measures to assure the rolling capability. So even if there is a fire, the train must be able to run for a certain time period. There are requirements for onboard fire detectors for all technical spaces. There are communication means on the trains. There is the emergency brake override, so you cannot stop the train in the tunnel. We have emergency lighting systems inside the train, and we have requirements for air conditioning in the train, that it's switched off upon alarm. Here are some examples. This is now a shuttle train, so a car for the truck drivers, but this applies similarly as well to other long-distance passenger trains. So we have to assure a certain running capability, even if the train is under fire. The driver must be protected. He must have certain breathing equipment in his working space, so to protect himself. And there are fire protection measures for passengers and freight of road vehicles, particular ones as shown, listed here. Here are just some pictures, fire extinguisher, or today there is no emergency brake really, but only an alarm, so the train does not stop immediately upon using this brake. That's then upon the decision of the train driver. Another thing is to relieve as well the train driver from many different tasks. He has in his cockpit one central button, some emergency button, and this button then does various activities. So again, certain doors inside the train are closed, loudspeaker announcements are triggered, there is the light is changed in the coaches, full light, doors opening is stopped or is released depending on the setting. Air conditioning is out, and so on and so on. So there are a couple of things which are then activated just by one button by the train driver. Then we have for communication internal loudspeakers, or for the evacuation in the tunnel a megaphone. Of course, all these measures have a limited efficiency. If the train is, let's say, 400 meters, you will not hear anything with the megaphone which comes away from 400 meters, but at least it's a mean to reduce certain or to reduce the consequences of certain fires. Then I guess we are coming more and more to the end and towards the coffee break, but there are some final slides about train evacuation and information for emergency forces. So it's important, of course, similar to safety advices in a plane, to advise the train passengers what to do. So where to evacuate, then how to behave in an emergency as well in a tunnel, and how you, for example, can in an emergency as well deblock doors or windows in case of emergency. So all this is part of the train equipment and train requirements. Then there is a set of information which you have to provide to the passengers, written by pictograms as handout or as major documents or movies for training purposes, especially for the train staff, or on the screens in a train. More and more trains have live entertainment in the trains, and then you can provide all these information which are given here on such a sheet as well. Of course, they must be then in different languages because you have perhaps international passengers, so you must address them in their, or try to address as many in their language. Then, final slide here on safety information, or almost final slide as well for passenger train. So this is another example what is done in a train in England. So you see here all the essential information, how to evacuate from the train, what to do in case of emergency. Which is important as well is that the rescue forces are informed, so they must know, the fireman must know where can you enter a vehicle, where can you interfere with the door opening mechanisms, where can you interfere with the emergency brakes and so on, where to access the trains, where are emergency openings. So for rolling stock, you need to prepare such fact sheets or checklists for the emergency forces as well. So it's not only for the passengers and staff, but as well for them. Well, I guess this is at least the first part of the presentation. So this was maybe very general, but again, just showing this book, it's very, there are many aspects to look at, and what I just introduced you to were just the sort of the headlines of these topics on fire safety of rail or metro systems. I guess now it's the time for a coffee break.
Yeah, I think so.
Okay. So I will continue then after the break with tunnel ventilation of rail tunnels.
Okay, many thanks, Peter.
Bueno, le agradecemos con un aplauso, por favor.